So like there wasn't anything for me. Like you can see here.
All right, let's do a example on the board together, and then I'm going to give you this. Everybody? Everybody? Listen to me now. We're going to do an example on the board together. Then I'm going to give you a worksheet's got 2 problems I want you to do on your own. Then we're going to do an example of a percentage hypothesis test. A couple of those, and then we're going to call it a day. So let's do this. While I'm thinking about it, the way the homework works, 2 things. Section 9.5 is the only place they have complete hypothesis test problems. The sections before that break out the steps individually, right? So after today, you can just go straight to 9.5 and then go back and do the other sections because they're only just parts of this. Are you guys with me? So 9.5 is, and in 9.5 they reference, this is the second thing. 9.5 they reference a worksheet in the back of the book they want you to follow. Screw that shit. You know exactly what you do. These 5 steps for me. The worksheet in the back is based on doing it all in the calculator, and you don't have that kind of teacher. So do that. Do these steps. Okay, so let's do one. I'm going to do an example showing a little bit different stuff. Let's say we feel the average grade in 4-week stats courses is not, well, I'm sorry, let's say that we feel this, the average is 80%. Whoa, we're crazy. So then we take a sample. Let's say, what's the matter? Let's say we sample 61 students, and we find a mean, oh, this poor little dude is dying. Ooh, of 77.2, and a standard deviation of, what you got, Jeff? I don't know, Jeff. 12.07. Okay. Then I can say something like test the claim at using a level of significance of 0.05. Dude. Okay, so that's the groundwork. That's everything just morphed it. Yes.
What's the verb between and?
Where?
Mean of and what?
Standard deviation.
Okay.
It's not in the deviation. I specifically didn't want to put a symbol there so that you could figure out this on that appropriate step. So 1. So we get the idea? So we made a claim. We're going to test it. We took a sample. Then we're going to test it. Is that equal to 80? No, but we're past that now. That's not good enough. It's got to be far enough away from 80 because it's just a poor little sample. So a sample's got to be like really good evidence. What is the claim in mathish? Yeah, I shouldn't make it as a percentage. I'm sorry. It's a mean, so 80. You with me? I don't want to. We're not doing a percentage problem yet. That's my bad. It's just the mean of 80. So yeah, the claim is mu equals 80. You guys with me? Yes. Level of significance. What's the symbol for that? Fish. I like fish. Or alpha. He's the alpha fish. Even better than the beta. Okay. everybody with this so far? I mean, you can tell that's the claim. We feel it is 80. Okay, that's the freaking claim. And we're going to test that claim using the sample. That doesn't show up till the fourth step. Because we normally have to figure out what the shit we're talking about before we even take a sample. So obviously I'm trying to warn you against this mistake that people make. They put that number in the claim. How can I make a claim about a number I don't know yet? Okay. Which one is that? Yeah, it's the whole Y. It's got an equal sign on it. It's got an actual equal sign. So what's the hot? Say again, sir? Yes. So is this one tail or two tail? Two tail. Not equal to, it could be up or down. I like it. Please don't tell me that it's less than or something, because 70, no. Again, when I'm setting these up, I don't know that yet. But as a problem, I got to give you everything so you can use it all. The claim is equal to, so this has got to be not equal to. So it's a two-tailed test. Wow. Okay. Next step is, what do I use, Z or T? Nort. Is it normal? Yes, because when it's 61,
And we know
greater
the
than
standard deviation.
check. Sorry?
And we know the standard deviation.
See that phrase, not to pick on you, Austin, right? I'm not picking on you. Phrase makes no sense. And it's not just you. A lot of people are going to say, this, we know the standard deviation. Why does it not make sense to say the standard deviation? Because there are two types. Which type do I know? That tells me the distinction there, right? We always got to know some standard deviation. It's just which one do I know? Why is it the sample one? Because that came from the sample. Do you see that? So I'm not going to just tell you, you got a sample standard deviation. I'm not going to use the letter S. You got to read it and realize, where did that come from? It came from the sample. So that's S. So what do I say here? So I can say sigma unknown, or I can say only know S, or I can whatever. So what does that mean I can use? That I have to use? Gotta use T-square, I like it. Okay. Boop. That part, you're gonna get seasick when you watch this. Sorry. Woo-hoo. So what are we talking about? What can we use to talk about it? Next two steps are the heart of a hypothesis test. How far away is far away enough? And how far away did we get? Kind of makes sense. Set the benchmark and then run. And then see what happens, right? So how do I get the rejection region? What do I need to know? We're using T-scores. So I need to know a little more than normal. You have to think about all that. What's alpha? You do have to think about it, but not that detailed. What's alpha? 0.05. Alpha is 0.05. It's a two-tailed test, right? So now you know which row to look at. You don't have to get into the deep weeds on that. You just know that it's two-tail 0.05. You know where to look on the T-score chart now, right? Where am I going to stop? Degrees of freedom? 60. Find the T-score. Really? Is it? Neat. I don't know. Let's see. Maybe I should find it too. So 0.05, two tails, 60. Kick ass. It is exactly 2. That's crazy. How many tail tests? Oh, sorry.
Where did you get 60?
What's n?
Oh, 60.
And then degrees of freedom is always n minus 1. Or not always, but so far.
I was just asking us out the degrees of freedom.
Yes, n minus 1 is the only one we know yet. That formula for the degrees of freedom. Two-tailed test, right? So what am I going to put here and here? You do it. What do you figure out the t-score is? 2. But I know it's a two-tailed test, so what goes in there? And
Negative
2 and negative 2, yeah. It's a two-tailed test, so I better identify both sides. Or where do I shade? Yes, beautiful. Always in the tails. That's the whole point of this, right? Because the HO thinks it's in there. So to show evidence that the HO is wrong, I've got to find something that's out here. Do you see how that makes almost, I don't want to say almost too much sense, but something like, you ain't made sense today yet, Jeff. Shit. The null thinks it's in there. To find evidence that he's wrong, then I got to find a sample way out there. Let that make sense. Oh, you think it's there? Well, look what I did. I got way this shit over there. You got to be wrong within a certain percentage certainty. Okay, maybe. So now, well, how do I say this in words? Oh shit, there's two sides. Oh shit. If T star is less than negative 2, or T star is greater than 2, we can do what? Never accept anything. Sorry.
Show you did.
We can reject the hoe. That's a good thing. My dean is gonna be like, are you calling your students? No, dean. Which I can also say the same way. I can say the same idea, but in a different way. If I reject the one guy, I think the other guy is right. Yes. You should. Because again, it's going to help you word your conclusion correctly. Yeah. Plus, it just makes sure that I know that you know what the hell you're talking about. So we've set up what evidence, where evidence starts. In this case, it kind of matches up with our old idea of unusual, right? It's 2 steps away. That's kind of crazy. Coincidentally. So if I find a sample that's more than this far away from this guy, that means that this guy looks to be wrong. I can reject this. That makes almost too much sense. So the next step, of course, is how far away did my sample get? So what do I know about my sample? Yeah, the mean is 0.2. What's the standard deviation? 12.07. And here's the part where people still are confused about this. Yeah, that's a sample standard deviation, but it's a spread of individual grades. I still need to change that to be for groups of 61. So don't say to me, it already is an S. That statement makes 0 sense. When I change sigma to sigma x bar, it's still a population standard deviation. It's just for groups. So that's for individuals right now. I got to make it into the one for groups, always. So what's Sx bar? 12.07 divided by the square root of 61. Is that like 1.6? I don't know. Just making shit up. What is it? It's not bad. 1.55. It's a standard deviation, so you gotta take out 1.545? 5454. 5454. Okay, 1.545. You can take it more if you want to, of course. It's got to be at least 3. And then I just make a z-square out of that, right? And I happen to call it z star. So what goes first up here? The first thing is always my data. What's my data? 77.2. Minus what the middle is supposed to be. What am I assuming the middle would be? 80. Divided by that new spread. Curious, I just made all this shit up. How's it come out? Comes out to just under 2, I think. Well, it came out really close to what it... Yeah, it's like 1.8. Is it? 1 point what exactly? 1.81? Damn, that's good, Jeff. Shit. Negative, of course. Darn it. That makes sense.
It's always in that order. Like it's always
Yes.
NV.
Yes, because with hypothesis tests, you are always assuming that the number from the claim is the real middle. That gets things going. So it's always my data minus the middle, where I'm always assuming this is the middle. Of course, did my sample show up above or below this? Which makes sense about why it's negative. It's below what I'm assuming the middle to be. Did we make it far enough away? No, we failed. We suck. Why in this case, let me see if you guys get this. We did fail. The test failed. We did not find evidence. Why is that okay for us? What was our claim?
That's an average.
Our claim was the hope, right? Did we find evidence to reject this? No, so we're actually happy. Do you guys see that? So that's how science works. I think this. Let me go try to prove me wrong. I mean, that's how science works. And so we're always like, we don't even hope that we don't, to be honest. Like I said earlier, we're like, oh, cool, I'm wrong. That's so awesome. What could it be? Holy shit, I have no idea. Anyway, sorry. So I can say right now, quick little phrase. We didn't make it far enough. We're at negative 1.81. We're like right there. So we didn't quite make it far enough away. So we fail to reject the null. Which I can also say is fail to support the high. But of course, which one am I going to use? I'm sorry, the high. What was my claim, like I just said? The null. So I'm going to use this language when I write my conclusion. You can always tell exactly how you're going to write the conclusion based on which one would you claim. I always say that, and people just guess and hope. 50-50 shot, support or reject. So let's write this conclusion. So step 5 is the conclusion. So we failed. We have not found sufficient evidence. So what? Reject the claim that yeah, and then you can just copy. This is one place where plagiarism is fun. Right? That the average grade in 4-week stats courses is 80. Woo! So let me give you this. And you guys just go to town on this. So there's the front and the back. I want you to do both problems. Then we'll do them, and then we'll do a problem, proportion problem, a percentage problem. And then we'll leave. Yeah.
The average number of headaches that Jeff causes.